and welcome back. Today I am going to explain to you the easy way of negotiating extremely curved canals using HANUDENT files. I don't use stainless steel files at all in this technique. It is basically a combination of ground down and step back technique wherein we rely entirely on the efficacy or efficiency of the rotary files.
The conventional technique uses hand files, which is made up of stainless steel, to reach till the apex using a glide path. Then that is followed by using of rotary files. The disadvantage is that they uses stainless steel file. This stainless steel file, when it passes through the curvature, it is not flexible, so it can fracture, and sometimes what happens is when it reaches a curve, there can be a step formation in the curve resulting in ledge and then complete blockage of the canal. So when you are using a stainless steel file, what happens is you remove some amount of resistance from the coronal portion, then you again move down to the earth's apex, you meet again resistance, but actually the first resistance in the coronal portion is not removed even if you have gone past it, because the stainless steel file is basically a tapered file. It is 2%, but it is still tapered. So even if the first resistance is overcome, still the resistance keep increasing because the files are tapered. It is not a zero taper file. So what happens ultimately when it reaches the apex, there are multiple areas where the file is being stressed. So this can result in fracture. In the conventional technique, we have been taught to use stainless steel files from the occlusal portion, the coronal portion towards apex by using a glide files. These files are actually not zero taper, they are actually 2%. So that means to say that from the tip to towards the handle there is an increase by 2%. So once you introduce this into the canal, in the coronal portion you meet first resistance, then we overcome the resistance, move towards the apex, we find multiple areas of resistance. So the file in its length is stressed in multiple areas. So chances of fracture is always there with these kind of files. But if you would have enlarged the coronal portion before going down, chances of resistance or stress and strain in the files becomes lesser. So that is why I always prefer a crown down technique than using a glide. Whenever you use a file towards apex, initial coronal interferences has to be removed. Since these files are not flexible, what will happen is once it reaches the curvature, it can result in formation of a step in the curvature, resulting in ledge, and then further negotiation into the curvature, beyond the curvature, becomes very difficult. Pre-curving is not always possible, because when you pre-curve the instrument, the pre-curved portion has to pass through the canal. So the canal has to be wider for the pre-curving to negotiate the canal. So in a narrow canal, pre-curving won't be possible. Pre-curving can be done when you have a gradual curvature. Another problem with this using stainless steel file is that once you have a curvature, as the stainless steel file progresses, when it comes to the curvature, what happens? There can be a step formation because these files are not flexible. So that can lead to non-negotiation of the canal beyond the curve, that portion. So it forms a step and then gets blocked. In curvatures, I prefer a no hands file technique using HANUDENT files. Basically, the technique involves preparation by ground down technique till the curvature, and it uses a step back technique beyond the curvature. The working length is measured from the RVG, a line connecting the curves from the occlusal table to the apex is done and it is measured. 2 mm is reduced from that to determine the working length. That is used as the working length. This is done because the curvature will start straightening and we lose the length, and to compensate for error in the RVG. Also, you are supposed to measure the length from the occlusal table to the curve. This is because we have a plan of doing crown down technique till the curvature. The length from the occlusal table to the apex is measured by connecting all the curves. So, once you determine the length from the occlusal table to the apex, reduce 1 to 2 millimeter and determine that as the working length. Select that as the working length. The technique is that you use crown down till the curvature. Basically use a 6% 30 size HANUDENT files, rotary files, passively into the coronal portion. Do not apply apical pressure. Let the instrument, the rotation and the torque of the machine endomotor carry it forward to the apex till the resistance is met. Don't go beyond the resistance. Sometimes what happens, the resistance would have because of the large canal, sometimes we will reach the curvature. If not, you can use 4% 25 size again passively to go till the resistance is met apically. If you have reached the curve by using 25 size 4%, then stop it there. If not, use a smaller size, say 20 size 4%, and try going apically till the resistance is met. If again it has not reached the apex, use smaller size 17 size 4% till you reach the curvature. Once you have reached the curvature, a step back technique is used. You can start using path files, which is the smallest one, 13 size 2%, and work till the working length, followed by 16 size 2% and then 19 size 2%. After that, you can use 17 size 4% till the apex, followed by 20 size and 25 size 4% till the working length. In this technique, I usually use a crown down technique till the curvature, and beyond the curvature it is a step back technique. I start off with a larger size 30 size 6% tapered rotary files and go till I meet the resistance. After that, I will use a smaller size 25 size 4% again till the resistance is met. After that, if I have not reached the curvature, then I will shift to 20 size 4% and reach till the curvature. Once I have reached the curvature, the canal is enlarged very well so that 2% files will go easily through that till the apex. So it is step back by using 13 size 2% path files till the apex. Then I shift to incrementally to 16 size 2%. That is, then I enlarge to 2% 19 size till the apex. Now I will start using 4% till the apex. So that is, I start with yellow, that is 4% 20 size till the apex, then 25 size 4% till the apex. So it is basically a combination of crown down and step back from there till the apex. So what happens is, it is a free flow for this 2% files till the apex. 2% are not under stress, torsional as well as cyclic stress in compared to the graded taper ones. So the graded taper ones are used till the curvature, and beyond the curvature initially by step back technique. So the rationale behind using a combination of crown down and step back technique in curved canal is that the greater taper files like 4% and 6%, they have got less cyclic fatigue resistance in comparison to 2% tapered files. Cyclic fatigue resistance means the ability to undergo compression and tension. You know that in a curvature what happens on the side which it bends, you have greater amount, that is the outer surface of the curvature, you have greater amount of tension, and the other side, inner side, you have compression. So cyclic fatigue is the ability for the file to resist compression and tension. So naturally when the diameter increases, chances of it to resist is less. So that is why I advise using 2% taper beyond the curvature. So less chances of fracture. So by using crown down, all the interference in the coronal portion is removed before you moving down. So especially that the instrument is not subjected to any kind of torsional as well as less amount of cyclic fatigue. Once the coronal portion is enlarged, what happens? The 2% easily, smoothly goes down to the apex without any cyclic fatigue. Now see this, if you are taking the instrument, hand instrument, stainless steel instrument, from the coronal portion till the apex, how much strain will be there in the file? No matter how much our lubrication, how much our glide path you have created, it will be under lot of stress. So chances of fracture is always there. Now see the figure 2. What happened? The curvature, the canal beyond, above the curvature is enlarged highly. Now the apical portion beyond the curvature is narrow. So now once you introduce 2% rotary, it will glide easily and enlarge the canal as in figure 3. Quick points for successful endodontics in curved canals. Never use a stainless steel file in a curved canal. You can use if your tactile sensation is too good. But still you hold a risk. How much ever you are experienced, how much ever tactile sense you have, you hold a chance of fracturing and ledging in a curved canal. Always remove all the coronal interferences before barging ahead, going forward beyond the curvature. Always all the coronal interference has to be removed by using crown down technique before going to the curvature. So that is where the combination of crown down and step back technique works well. Always check for unwinding of files during each insertion. Discard all files used beyond a curve. Why I recommend using HANUDENT file is that when you start understanding it has got a high resistance against compression and tension, which is cyclic fatigue resistance, which is most desired property when using in a curved canal. Because once you have a curvature, what happens? Outer surface of the curvature in the file will be undergoing lot of tension, whereas inner portion of the curvature will be in compression. So when periods of compression and tension comes, what happens? It can fracture. But HANUDENT files has got high amount of resistance to overcome this. They also have very good torsional resistance which is needed in narrow canals. So that is why I recommend HANUDENT files when you operate for a higher successful endodontics. Thank you for watching this video, and if you have any doubts, you can contact me in my WhatsApp number 9447018697. Till I come up with the next video, it's goodbye from me.